Hello guys, welcome back to another video. Today we're going to be solving question 5 and 6 of the MIT Integration B qualifying exam 2022. So let's not waste any more time and get right into it. So here's the first question of our video today. It is the integral of x over square root of x plus 1 plus square root of x minus 1 with respect to x. So the first step to solving this integral is to rewrite it and to simplify it. So we're going to times both sides by square root of x plus 1 plus square root of x minus 1. So these will cancel out, right? And we'll just get the integral of x square root of x plus 1 plus x square root of x minus 1 divided by 2, right? That's what we'll get. Now then, we can separate this integral out into two integrals, just like this. So that's such that we'll get a half of the integral x square root of x plus 1 with respect to x minus a half of the integral square root of x minus 1 x here with respect to x. So we're going to solve this integral first. So to solve this integral, we're going to use u substitution. So we're going to let u equal to x plus 1, such that then du by dx will be 1. And that means that dx is equal to du, which is then going to give us the integral of u to the power of 3 over 2 minus square root of u du. So now we'll get the integral of u to the power of 3 over 2 with respect to u minus the integral of square root of u du. Now we will be solving this integral right here by using the power rule, which will give us 2u to the power of 5 over 2 divided by 5. So now we're going to solve this integral by the same method, which is going to give us 2u to the power of 3 over 2 divided by 3. Now, after all of that, we will plug in the solved integrals, which will give us 2 times x plus 1 over to the power of 5 over 2 divided by 5 minus 2 times x plus 1 to the power of 3 over 2 divided by 3. Now remember, now we need to solve this integral right here. So let's go ahead and do that. We will now solve the integral of square root of x minus 1 with respect to x. We're going to let u equal to x minus 1, which then differentiated is going to give us 1. And then this means again dx is equal to du. So then this plugged in is going to give us the integral of u to the power of 3 over 2 plus the square root of u with respect to u. Now we're going to break down this integral even further. We're going to simplify it to make it easier for us to solve. So we're going to get the integral of u to the power of 3 over 2 respect to u plus the integral of square root of u with respect to u. Solving the first integral by using the power rule will give us 2u to the power of 5 over 2 divided by 5. Now we can solve this integral easily because we know we have already solved it before. And the answer then is 2u to the power of 3 over 2 divided by 3. Now, after all of that, we will now plug in these integrals. We will plug in all of this and minus them. So let's go ahead and do that. Now, finally, after plugging the integrals in, we will get our final answer. Now, as you can see, we have all of this divided by 2, and we can even simplify this even further. All of these 2's will cancel out, which will give us our final answer, which is just this right here, plus c. Done. And now let's not waste any more time and get right into the 6th question. So here is the 6th question. The integral of upper bound pi and lower bound 0 of cos of x plus cos of x with respect to x. Now the first step to this is we can simplify this into cos of x times cos of x, right? And next thing we're going to do is we're going to use a u substitution, right? We're going to let u equal to pi over 2 minus x. Now we're going to have this integral of upper bound pi over 2 and lower bound negative pi over 2 of sine of u times cos of sine of u. Now this is just equal to 0. So the next thing we are going to do is have sine of pi minus u, which is going to equal cos of u. This is going to give us cos of u of sine of u, which is also equal to 0. So in the end, all of this is just equal to 0. And that is the 6th question solved. So, as always, thank you guys for watching. Hope you liked the video, and I'll see you in a new one. Goodbye.